सो लास्ट टाइम हमने लॉज ऑफ मोशन चैप्टर खत्म किया था, थ्योरी पूरा कवर किया था. सो लेट अस सी द न्यूमेरिकल्स नाउ. Okay, I hope you can see the board here. First of all, let us discuss all the formulae from this chapter. तो important formulae जो है तो वो हम एक बार डिस्कस करेंगे फटाफट. तो जैसे कि सबसे पहले हम देखते हैं न्यूटन्स लॉज. तो उसमें लेकिन याद रखो इसमें कि इस पूरे चैप्टर के अंदर हमको काइनेमेटिक इक्वेशंस तो यूज करने ही करने हैं. तो जो कि हमको पता है ऑलरेडी, v is equal to u plus at. This is the first kinematical equation. S is going to be ut plus half at square. It is going to be the second kinematical equation. And the third one is v square is equal to u square plus 2as. This is the third kinematical equation. Along with this, we can just have the fourth one, which is s equal to u plus v upon 2, that is the average velocity multiplied by time. So this can be regarded as a fourth kinematical equation, remember. Then again, in this chapter we have just seen large number of formulae related to momentum, force, work done, and energies. So the first of all, we can just talk about the momentum. It is the product of mass and velocity. Then again, the force is going to be the product of mass and acceleration. Actually, basic formula for the force is simply the rate of change of momentum actually. Okay. Then again, we can have the formula for law of conservation of momentum, which tells us simply that m1u1 plus m2u2 is going to be equal to m1v1 plus m2v2 for the two different bodies traveling with these two different velocities. Then after that, we also seen the elastic collision and inelastic collision. So we have the formula for coefficient of restitution, which is simply the velocity of recession of the two bodies, that means v2 minus v1 upon the velocity of approach, that is going to be u1 minus u2. So this is the coefficient of restitution. And in case of an elastic collision, this will be 1. In case of an inelastic collision, it will be 0 to 1. And in case of perfectly inelastic collision, the coefficient of restitution will be 0. In case of head-on elastic collision, we can just have the formula for, okay, one more thing, coefficient of restitution is obtained to be simply equal to root of, or first of all, it will be equal to v2 upon simply v upon u. If suppose one of the bodies is going to be at rest, and this can also be written to be simply equal to root of h2 upon h1. If suppose a ball is just released from the height h1 and just bounce up to the height h2. Yes. And again, we can just have the formula for the velocities after collision in case of head-on perfectly elastic collision. So v1 and v2. So v1 can be obtained to be simply m1 minus m2 upon m1 plus m2 into u1 plus, here it is again, 2m2 upon m1 plus m2 into u2. In the same way here, we have the formula for v2 also, that is 2m1 upon m1 plus m2 into u1 minus I'll just take it as plus only, and here it will be m2 minus m1, that is to be divided by m1 plus m2 into u2. Okay. Along with this, in case of an elastic collision, one more formula is worth noting, that u1 plus v1 is equal to u2 plus v2. Remember this correctly. Okay. Then again, in case of inelastic collision, we can just have the formulae, which are just memory-based formulae. v1 can be written to be actually equal to so v1 will be actually equal to m1 minus e times of m2 divided by m1 plus m2 as it is into u1, and plus here in the second bracket it will be m2 into 1 plus e, again which is divided by m1 plus m2 into u2, and here v2 can be written to be simply equal to, again here it will be m1 into 1 plus e divided by m1 plus m2 into u1, plus in the second bracket it will be m2 minus e times of m1 upon m1 plus m2 in this way, that is multiplied by u2. All right. Then we can just have this formula for loss in kinetic energy in case of an inelastic collision. तो inelastic collision के अंदर जो loss in kinetic energy होता है, in case of perfectly inelastic collision, the loss in kinetic energy is given by half into mu into u1 minus u2 का whole square. Okay, where mu is actually going to be the reduced mass, which is going to be actually m1 m2 upon m1 plus m2. This term is called as actually the reduced mass. And in the same way, in case of an general inelastic collision, okay, so the expression for the loss in kinetic energy happens to be actually mu again into u1 minus u2 the whole square into 1 minus e square actually. Then again, we can just have the work done. Formula for work done. Basic formula for work done is simply the product of force and displacement. But so far as the force is constant and displacement is taken place in the same direction as that of the work done, then we can use this formula here. But if suppose force is not in the same direction as that of the displacement, then we will have to resolve the force and take its component along the displacement. And in that case, the formula for work done in that case will be F into S into cos theta, where theta is the angle between force and displacement. Okay, तो force और displacement के बीच में का angle यहाँ पे theta होता है. Then again, if suppose we have the force which is variable, then in that case, the work done in this case can be found out to be simply F into ds. Okay, integration of F into dx. This can also be written as F bar dot S bar in vector form. And in general, in case when the force is not constant, and also it is not in the same direction as that of displacement, then in that case we can just have the formula for work done to be simply integration of F bar dot ds bar, or we can call it as dr bar in this case, where dr bar is nothing but the dx into I bar plus dy into j bar. Just forget about this. We can just use it in the numericals directly. Okay. So this is the formula for finding the work done. And also we can have that power. Power in this case is simply the rate of doing work. That means simply the work done upon time is called as the power. Or we can just say the derivative dw by dt. This is called as the power. And one more formula is there for power, which is the product of instantaneous force and instantaneous velocity. The power is always the product of force and velocity. Remember, this is the formula for power in general. And then again, the potential energy, kinetic energy, have the similar formula. So potential energy, gravitational potential energy in general is having the formula that is mgh. Remember, and then again it is the formula for kinetic energy. Kinetic energy is going to be equal to half of mv square, no doubt. And also that there is a work energy principle, which tells us simply that whatever work is done by conservative forces plus non-conservative forces, the total work done by all forces is always equal to the change in kinetic energy. That means kf minus ki. Here this is the law of, you can say, the work energy principle here, which tells us simply that whatever work is done is always going to be converted into the change in kinetic energy of the bodies. In this case, the work done by conservative forces especially can be converted as the change in potential energy. So the work done by conservative forces appears as a negative change in potential energy. That means uf minus ui. ये हो गया negative change in potential energy. But the work done by non-conservative forces never appears as a change in potential energy actually. So therefore, the total work done by non-conservative forces is actually going to be equal to the total energy, total final energy minus total initial energy. This can also be the one of the form of law work energy principle. Remember, which tells us that the total work done by non-conservative forces is always equal to the change in total energy of the body, where total energy, final total energy, is going to be the final potential energy plus final kinetic energy. And in the same time, the initial value of total energy will actually be the initial potential energy plus initial kinetic energy. That's it. So and then again we can have the law of conservation of momentum. In the same way as law of conservation of momentum, there is a law of momentum impulse theorem. First of all, we can just understand what is impulse actually. Impulse is going to be the product of force and time for which that force acts actually. But this will be used only when the force is constant over time. But if suppose it is not, then in that case, the impulse can be defined to be simply equal to the integration of force into this time interval. So if the force is not constant, it's variable, then in that case, we can just divide the force, the interval, into large number of small intervals and find out the impulse in each of the interval and just add it up so as to get the total impulse by the force. So this is the concept of impulse, remember. And here the impulse momentum theorem tells us simply that the impulse exerted by the force is always equal to the change in momentum. Remember, impulse is equal to the change in momentum. It can also be put in vector form. That means we can just say that the impulse is actually going to be integration of f bar dot dt. This is the impulse actually, which must be exactly equal to the change in momentum. That means it will be final momentum minus initial momentum in this way. So this is called as the impulse momentum theorem. Then we have seen the concept of torque, right? So torque is given by the formula torque is equal to r bar cross f bar. This is the most general formula for the torque. But if suppose force is already perpendicular to the torque, then the magnitude of the torque can be simply found out to be equal to R into F. But if it is not, if suppose force is not perpendicular to the moment arm, then in that case, the magnitude of the torque can be found out actually to be equal to R F sine theta, where theta is going to be the angle between F bar and R bar, remember. And moment of couple, okay, moment of couple can also be found out to be simply equal to couple is produced by two forces. So moment of couple is going to be equal to the product of one force, any one force, and multiplied by the perpendicular distance between two forces. We can just denote it by AB. So this moment of couple is going to be the product of cross product of force and the perpendicular distance between two forces in this way. So this is the concept of moment of couple. And then we can just have the condition of equilibrium, the condition of linear equilibrium, or we can just say translational equilibrium, is that summation of all the forces acting on the body must be equal to 0. And the condition of rotational equilibrium is that the summation of all the torques acting on a body is actually going to be 0. These are the two conditions of equilibrium. And also we have seen the concept of center of mass. The center of mass of 2-particle system, 3-particle system, and n-particle system have been just already derived in last lectures. So we can just have this the center of mass of 2-particle system. That means x coordinate of center of mass can be written to be simply equal to summation of mi xi divided by summation of mi. And y coordinate in the same way, and xz coordinate also can be find out in the same way. And also we can just see the center of mass of, in case of uniform body, the summation sign will just be replaced by integration sign. तो इस summation के बदले क्या आ जाएगा यहाँ पे integration आ जाएगा बस अगर uniform body है तो. So all these are the formulae, we have just seen it in this chapter. So let us start with the numericals now. So this is your textbook. We can just consider this first question here. Okay, so this is the first question. Just read it carefully. A truck of mass 5 ton. Okay, a truck of mass 5 ton is traveling on a horizontal road with 36 km/h. ये हो गया उसका velocity. Okay, and stops on traveling 1 km after its engine fails suddenly. Okay, that means suppose that this is the road surface. Okay, and here it is the truck. Okay, so this is going to be the truck here, which is traveling in this direction. Suppose इस direction में वो move कर रहा है, जिसका speed यहाँ पे already दिया हुआ है. We can take it as a initial speed basically. तो इसका initial speed जो है वो दिया हुआ है यहाँ पे 36 km/h. Okay, we can consider it as u. So u is given to be 36 km/h. But as we know that this speed is measured in meter per second actually. So it should be expressed in terms of meter per second. So remember that this 36 kilometer per hour can be converted into meter per second by multiplying this by 5 by 18. Remember, इसको 5 by 18 से हमको मल्टीप्लाई करना होता है, तब जाके वो मीटर पर सेकेंड में कन्वर्ट हो जाता है. And the logic behind it is very simple. Kilometer per hour means, kilometer means 1000 meter, right? And hour means 3600 seconds, right? So we can just say this, these two zeros will just get cancelled straight away. And we can just cancel out this 10 and 36 by 2, so that we can just get these 2 5s are, and here it will be 2 18s are, correct? So in this way we get the factor 5 by 18 times of meter per second. So 1 kilometer per hour is always equal to 5 by 18 meter per second. So in order to convert the kilometer per hour into meter per second, you have to just multiply it by 5 by 18. Remember, so once we get multiply this here, we can just cancel out this 18 and 36 so as to get this 2 here, and we can just get this 10 meter per second as the initial speed of the truck. Okay, so that means the truck is already moving with 10 meter per second in this direction, and suppose the engine just fails suddenly. So after traveling 1 kilometer, the truck just stops. ये दिया हुआ यहाँ पे, इसका मतलब ये जो डिस्टेंस है यहाँ से लेके यहाँ तक का जो डिस्टेंस जहाँ पे वो स्टॉप होता है, तो उधर तक का जो डिस्टेंस है वो डिस्टेंस हमको दे रखा है, it's 1 kilometer here. So this is the distance at which the truck just stops. और ट्रक अगर स्टॉप हो गया तो इसका मतलब उसका फाइनल वेलोसिटी कितना हो जाएगा? We can just say that it will be 0, no doubt, and hence we can just get the final velocity to be 0 meter per second. And after traveling 1000 meter actually, तो ये 1 किलोमीटर मतलब ये क्या हो गया? 1000 मीटर हो गया. ये डिस्टेंस यहाँ पे दिया हुआ है 1000 मीटर. उतना डिस्टेंस ट्रैवल करने के बाद वो ट्रक जाके रुकता है. That means the displacement is also given to be 1000 meter. Yes. So if we just try to find out the acceleration of this body, because see, what we want is what fraction of its weight is the frictional force exerted by the road. Now see, why this truck stops is due to the frictional force. So frictional force is the only force acting on this truck after its engine fails, because when the engine is running, there are two forces acting on this truck. One is due to the engine and other one is due to friction. But when the engine just fails acting or starting, it will no longer act as the force, but because of that, only frictional force will act on this truck in the backward direction, which will try to retard its motion, which will try to bring it at rest. And that's why this acceleration of the truck can be actually found out by using this simple formula. Just we can have v square minus u square upon s. एक्सेलरेशन के लिए ये फॉर्मूला हम यूज कर सकते हैं, जो कि हमारे थर्ड काइनेमेटिक इक्वेशन का ही एक कॉन्सिक्वेंस है, जो तुमको पता है ऑलरेडी. v स्क्वायर इक्वल टू u स्क्वायर प्लस 2as. ये फॉर्मूला हमारे पास है. इसमें से हमने ये u स्क्वायर को उस तरफ लाया और 2as को नीचे डाल दिया, जिसकी वजह से ये v स्क्वायर माइनस u स्क्वायर अपॉन 2as ये फॉर्मूला हमको मिल गया. ठीक है, इसका ये कंक्लूजन है. So if you just 2s, so if you just replace all the values here, then we can just be able to get this v square. V मतलब नहीं, v मतलब 0. Okay, so 0 square minus u square. U is going to be 10 here, so we have to replace this 10 and uska v square, and that is to be divided by 2 times of s, where s is going to be this displacement, which is going to be 1000 meter. So we can just replace this s by 1000 meter here, and then just simplify this further so that we get this minus of 100 upon 2000, sorry. Okay, and hence we can just cancel out these 2 zeros from this numerator as well as denominator, and we can just get this as minus of 1 by 20 as the acceleration. Okay, so this is going to be the acceleration, no doubt. But here we can just understand what we want now. Just repeat the question again. ये लास्ट लाइन जो है क्वेश्चन का, फिर से एक बार पढ़ो। तो क्या कहता है वो, व्हाट फ्रैक्शन ऑफ इट्स वेट इज द फ्रिक्शनल फोर्स exerted by the rod. अभी इस वर्डिंग्स का मतलब हमको समझना है। What fraction of its weight is the frictional force? That means we want to find out the ratio of the frictional force, okay, frictional force to the weight of the body. तो इन दोनों का हमको रेशियो ढूंढ के निकालना है। Whenever we are asked to find out the what fraction of weight is the frictional force, that means we want to find out the ratio of this frictional force to the weight of the body. Remember, जब भी ऐसा हमको पूछा जाता है कि what fraction of, जैसे अगर सपोज पूछा कि what fraction of x is y, what does it mean? What fraction of x is y? तो मतलब हमको निकालना है y upon x. Actually, if y upon x comes out to be half, then what we can say? We can just say that y is equal to half of x. What does it mean? Y is half times x. मतलब what fraction of x is y is half. तो इसका आंसर आएगा half. तो इस तरह से ये जस्ट एक एग्जांपल हो गया। तो मैं यहाँ पे ये क्लियर करना चाहता हूँ कि whenever we are about to find what fraction of something is other something, then we can just find out the ratio of this second thing to this first one thing. Okay, मतलब जो ऑफ के बाद लिखा हुआ होता है वो हमको डालना है इधर डिनोमिनेटर में, और इज के बाद जो लिखा हुआ होता है उसको हमको पुट करना है इधर न्यूमरेटर में, बस याद रखना है। So whenever the questions of this type are to be solved, what fraction of x is y? That means we want to find out the ratio of y to x. Okay. So in order to find out the ratio of frictional force to the weight, we'll just find out the formula for frictional force. What is the formula for frictional force? Because see, since acceleration due to the friction is obtained here to be a, which is going to be minus 1 by 20, then we can just get the frictional force to be obtained to be mass of the body multiplied by acceleration of the frictional force, acceleration due to frictional force. And weight of the body can be actually written to be mass into gravity. वो तुमको पता है already. So if we just divide these two here, then this mass of the body will just get cancelled, and the ratio of frictional force to weight will be actually a by g simply, and hence we can just get that a by g can be replaced here. A is going to be actually minus 1 by 20. In magnitude, it will be simply 1 by 20. Okay. And that is to be divided by g, where g is nothing but acceleration due to gravity, which can be taken straight away to 10, to be 10. And hence we can just get this as, so यहाँ पे जो है 1 upon 20 divided by 10, मतलब ये 1 upon 20 into 10 हो गया वो, तो it will be 1 upon 200 in short. So this is the ratio of frictional force to the weight in this way. So, and one more question is asked here. If we assume that the story repeats for a car of mass 1 ton, now truck was of mass 5 ton, but actually mass is not used anywhere here in this example because mass has been just cancelled here in this step. And hence we can just understand that even if the same story just repeats for a truck car also, whose mass is changed of 1 ton, then can moving with same speed stops in a similar distance, then same how much will the fraction be? Okay, तो फ्रैक्शन मतलब ये फ्रिक्शनल फोर्स टू वेट, ये जो फ्रैक्शन है, ये फ्रैक्शन कार के केस में कितना होगा वो हमको ढूंढ के निकालना है। Again we can just understand that car, in case of the car also, this fraction will be the same only because mass is getting cancelled here in this case. तो वो ट्रक हो या कार हो उससे कोई फर्क नहीं पड़ता है। ट्रक का मास बड़ा है लेकिन वो भी कैंसिल ही होने वाला है यहाँ पे, और कार का मास छोटा होने वाला है लेकिन वो भी यहाँ पे कैंसिल ही होने वाला है। तो फाइनल आंसर इज गोइंग टू बी द सेम ओनली, एंड दैट्स व्हाई वी कैन जस्ट अंडरस्टैंड दैट दिस 1/200 will be the fraction in both of the cases, which is already there in this option in this way. Yes, let us see the next question. Just read this second question here. A lighter object A and a heavier object B, initially at rest. Okay. initially at rest. That means we can just show them by diagram. एक lighter object और एक heavier object A और B है और वो दोनों at rest है initially. Both are imparted the same linear momentum, which will start with greater kinetic energy, A or B, or both start with the same energy. Okay, so that means see here, one is the lighter object, which we can call it as A here. Okay, and this is the heavier object, which we can call it as a B. Now, if suppose the mass of this lighter object is going to be small m1 and the mass of heavier object is going to be m2 here, then it is given that both are imparted the same linear momentum. See, what does it mean? Actually, if suppose we want to impart both of the bodies the same linear momentum, that means if suppose we want to give this velocity v1 to this body, and we give the velocity v2 to the second body, then we can just say that the momentum of both of the bodies will be same only when v1 is going to be greater than v2. Just for example, see here, if suppose we have this first body of mass 100 kilogram, okay, ये चलो, हाँ ये चलो ठीक है, ये एक बॉडी है 100 किलोग्राम का और दूसरा एक बॉडी है सपोज 1000 किलोग्राम का, और अगर हम सपोज इन दोनों को अगर सेम मोमेंटम देना चाहते हैं, तो अगर इसको हमने मान लो कि एक 5 मीटर का वेलोसिटी, 5 मीटर पर सेकंड का वेलोसिटी अगर दे दिया फर्स्ट बॉडी को, ठीक है, so if you suppose the velocity of 5 meter per second is given to the first body, then in order to give the same momentum to both of the bodies, we can just have to give the momentum of velocity of 0.5 meter per second to the second body, so that the product of mass and velocity is going to be the momentum. Here the momentum of the body will be 100 multiplied by 5, which happens to be 500 actually, and here in this case 1000 multiplied by 0.5, which is actually going to be 500 once again. So देखो यहाँ पे, तो अगर मोमेंटम सेम बनाना है तो उसके लिए जिसका मास कम है उसको हमको ज्यादा वेलोसिटी देना पड़ेगा ठीक से, और जिसका मास ऑलरेडी ज्यादा है तो उसको हमको कम वेलोसिटी देना पड़ेगा, तब जाके दोनों का मोमेंटम सेम हो सकता है. तो यहाँ पे अगर हमको मोमेंटम अगर सेम चाहिए, since momentum of the first body is going to be the same as momentum of the second one, so but momentum is the product of mass and velocity, so first body will have its momentum to be simply equal to m1 into v1, correct, which is going to be equal to the momentum of the second body, which has to be equal to m2 into v2, correct. So that means if suppose since m1 is less than m2 but the product has to be the same, so that means v1 has to be greater actually than v2. ये समझ सकते हो ठीक से, because the product has to be the same. Product of m1 and v1 must be same as the product of m2 and v2, and this is possible only when if suppose m1 is already less than m2, then v1 has to be greater than v2, then and only the momentum can be equal. Okay, but because of this, so the question here is that which one will start with the greater kinetic energy. Now we want to compare their kinetic energies now. So if we just compare their kinetic energies, then K1 or K1 we can say, it will actually be equal to half of M1 into V1 square, right? And in the same way here, K2 can be written to be simply equal to kinetic energy of the second body can be written to be half of M2 into V2 square, correct? Now we want to compare these two. If suppose momentum are same, so we can just express this in terms of momentum here and get this as half of m1 v1 into v1 as it is, and here also we can just express it as half of m2 v2 into v2 again as it is. But here we can just say that this m1 into v1 is going to be p1, as we can just see here, and m2 into v2 is going to be p2, that is the momentum of the second body. So the next step we can just have that this k1 is actually going to be half of p1 into v1, right? And in this case here, the second body will have its kinetic energy k2, which is going to be equal to half of p2 into v2. But if we just compare these two, half is on its own place. P1 is replaced by P2 here, but P1 and P2 is same only. So we can just compare V1 and get the answer here. Since here we can just understand that V1 is greater than V2, what does it mean here? अगर V1 यहाँ पे बड़ा है, V2 छोटा है, तो उस केस में, और P1 P2 तो सेम ही है ऑलरेडी, तो K1 K2 में क्या रिलेशनशिप रहेगा? जरूर K1 बड़ा होगा K2 से, करेक्ट? तो इसलिए हम ये कंक्लूड कर सकते हैं कि K1 is going to be greater than K2, and that is the comparison of their kinetic energies. Finally, that means the body A will actually start with greater kinetic energy. So answer is going to be A. Yes. Atharva, kinetic energy is proportional to V square, but only in case when mass is constant, right? See, Atharva is saying that we know that the kinetic energy is equal to half mv square, right? So can't we say that this kinetic energy is directly proportional to simply V square? But it requires mass to be constant, which is not the case here, right? Okay, are you getting point? यहाँ पे अगर मास कांस्टेंट है, दो बॉडीज जो है वो दोनों का मास अगर सेम है, और फिर एक बॉडी को हमने कम वेलोसिटी दिया और दूसरे बॉडी को फिर ज्यादा वेलोसिटी दिया, तो इन दैट केस वी कैन जस्ट यूज दिस फैक्ट that kinetic energy is proportional to V square, no doubt. And in that case, we can just say that the kinetic energy is proportional to V square, and जिसका velocity ज़्यादा होगा, उसका kinetic energy भी ज़्यादा होगा, बिल्कुल. But the conclusion, this conclusion will just be wrong here in this case, just because mass is not given to be equal. Mass is given to be unequal. Here, the mass of A body is heavier. Sorry, A body is lighter, whereas body B is going to be a heavier one. That means the masses of the two bodies are going to be different. Okay. Again, that's what I'm saying here, that the mass cannot be considered as constant. It is actually mentioned here in this question that lighter object A and heavier object B. जो lighter और heavier का मतलब ही क्या होता है? These are the two words which distinguish the mass. Which these two words just gives us idea that M1 is going to be smaller. Lighter का मतलब ही क्या होता है? Mass of the body is going to be small. And heavier का मतलब ही होता है कि the mass of this body M2 is going to be greater. So masses are not same actually here. We cannot assume that the mass is same, even if they are saying that a lighter body and heavier body is already there. तो lighter और heavier ये words अगर उन्होंने use किए हैं, तो इसका मतलब वो दो bodies same mass के हो ही नहीं सकते हैं. Yes, but still we can approach this question by another point of view. एक दूसरा logic भी है जिसको use करके हम इस question को approach कर सकते हैं. देखो ठीक से वो भी आपको समझ में आता है क्या? See, kinetic energy is going to be actually half mv square. So we can just express this half mv square as half of m square v square upon m. Can we? Yes, no problem, no problem. Because we know that we can just multiply and divide by m anywhere, anytime. तो यहाँ पे हमने क्या किया? m से multiply divide कर दिया. तो यहाँ पे m square हो गया और यहाँ पे नीचे m आ गया. But as we know that this m square v square can actually be written to be mv the whole square, correct? And that is to be divided by m. That means finally we can just express this expression of kinetic energy in terms of the momentum in this way. The kinetic energy can be written as p square upon 2m. Do you agree with this? Okay, if you remember this formula of kinetic energy in terms of momentum, then we can just understand that kinetic energy for the first body, if you just consider the first body here, then kinetic energy of the first body can be written as K1, which will be actually equal to P1 square upon 2m1, correct? And K2, that is the kinetic energy of the second body here, K2, can be actually written to be equal to P2 square, that is the momentum of the body square, upon 2 times of M2. Okay, now if you just compare these two formulae here, then here P1 is same as P2. That is already given there in this question itself. Both are imparted with the same linear momentum. What does it mean? P1 is going to be same as P2. So since P1 is going to be same as P2, so we can just find out the value of P1 square from this here. So from here we can just get that P1 square is, or just take the ratio of these two equations itself. In दोनों equations का अगर हमने ratio ले लिया तो क्या होगा देखो ठीक से. So we can just get this K1 upon K2 simply equal to P1 square upon 2M1 into the reciprocal of this K2, which is actually going to be 2M2 upon P1 square, correct? But since this P1 square is, sorry, P2 square is going to be constant, its momentum is going to be constant. P1 is given to be same as P2. So therefore we can just cancel out this P1 square and P2 square. 2 को तो कभी भी cancel कर सकते हैं, no doubt. And what we left is K1 upon K2 is equal to simply M2 upon M1, correct? M2 upon M1. But as it is mentioned in the question that lighter object A, that means M1 is going to be smaller than heavier object B, that means M2, correct? So lighter object A का जो mass है वो हमने M1 लिया है, it should be less than the mass of the body B here, which is M2. So M1 is less than M2. ये तो इसमें से clear हो गया. अगर M1 less than M2 है तो इसका मतलब, see, if M1 is less than M2, so यहाँ पे numerator बड़ा है और denominator छोटा है, that means the ratio must be greater than 1, right? So since the ratio is going to be greater than 1, since because this M1 is less than M2, so the ratio of M2 is to M1 will be greater than 1. And since this ratio is greater than 1, means that this ratio must also be greater than 1, correct? And since K1 upon K2 is greater than 1, it means that, see here, if you just write that K1 upon K2 is greater than 1, means simply this K2 can be transferred that side, so as to get that K1 is greater than K2. That means the first body will just start with the greater velocity. That means the A option, means A body will just start with greater kinetic energy than B. That is the correct option, okay, which is already there. Getting this? Here, remember this formula also, which is worth important. Let us go to the next question. The third question in the line. Yes, it tells us that as I was standing on a weighing machine inside a lift, it recorded 50 kilogram weight. Suddenly, for a few seconds, it recorded 45 kilogram weight. What must have happened during that time? Explain with complete numerical analysis. Okay, see here, if suppose the lift is, suppose some object is situated in the lift, जैसा कि हमने already देखा था pseudo force के केस में. Suppose this is the lift, and suppose a person is just sitting in the lift. इस लिफ्ट के अंदर एक पर्सन यहाँ पे सपोज है. Okay, so see here, first of all, the lift recorded 50 kilogram weight. That means this must be the normal weight of the person. Okay, ये जो है, which is the which the weighing machine shows for a long time is going to be the normal ordinary weight of the person. That means the weight of the mass of the person is going to be 50. तो इसका मतलब अभी चलो m is going to be equal to 50 kilogram. ये दिया हुआ है. suddenly for few seconds it recorded 45 kilogram weight. What does it mean? Suddenly कुछ समय के लिए ये जो weighing machine है जिसके ऊपर वो person खड़ा है वो actually 45 किलोग्राम weight ये weight दिखाता है. इसका मतलब there must be a pseudo force acting on the person in the upward direction, which must be equal to which must be such that its weight has been reduced. Normal weight of the person is already acting on it in the downward direction, but due to the pseudo force, the effective weight will just be decreased. And we already seen it in the theory that the normal reaction when the lift is moving in the upward direction, sorry, when the lift moves in the downward direction, in that case, the pseudo force acts in the upward direction, and the normal reaction on the surface of the lift happens to be actually mg, that is the weight of the body, minus the pseudo force acting on it, that is m into a here. So we can just take this m common from this and get that the normal reaction to be simply equal to g minus a here. But the normal reaction is expressed as, यहाँ पे normal reaction जो है वो 45 किलोग्राम weight का हमको मिल रहा है. So we can just express this normal reaction as m dash into g, where m dash is going to be the weight shown by the weighing machine. So here we can just put the values, and here m dash is going to be 45, where g can be replaced by 10, or just keep it as it is, g only. And m is again 50, which is the normal mass of the body. So here it is going to be 50 and must be multiplied with g minus a here. So this is g minus a kept as it is. And we can just now simplify this further. So if we just take this 50 in the denominator in this side, or just cancel out this 50 and 45 here only. तो यहाँ पे अगर हम इस दोनों को अगर कैंसिल करते हैं तो ये 5 से हम रिड्यूस कर सकते हैं इसको. 5 9s are, and here it will be 5 10s are, correct है? So in the next step we can just have this simplified as 9 times of g is equal to 10 times of g minus a, right? And if we just simplify this further, then we can just get that 9g is going to be equal to 10g minus 10a, right? So that we can just shuffle the terms, just bring this 10a in this side and just shift this 9g in that side, so that we can just get this as 10a, which is equal to okay, so 10a is brought in this side, 10g as it is, and here this minus 9g will be left in that side. So this is minus 9g. Okay, so 10a actually happens to be simply 10g minus 9g, matlab 1g, and hence we can just get that acceleration a of the lift is going to be g by 10. And then this numerical analysis tells us that the lift has been accelerated in the downward direction with an acceleration of 1/10 of acceleration due to gravity. That is, अभी gravity का acceleration कितना है हमको पता है already. It is 10 meter per second square. So if we just put the value of that g here, then we can just get this 10 divided by 10. That means it becomes 1 meter per second square. So this must be the acceleration of the lift in the downward direction. Okay, so lift must be moving down with the acceleration of g by 10 meter per second square. Okay, so just have this screenshot or if suppose we have some doubt, we can just discuss it in the chat box. Okay, let us go to the next question. It is diagram based question actually. Okay, just read this question carefully. The figure below shows a block of mass 35 kilogram resting on a table. A table is so rough that it offers a self-adjusting resistive force, 10% of the weight of the block, for its sliding motion along the table. Okay, that means block का जो frictional force है, तो वो कितना है? It is going to be 10% of the weight of the block. Okay, a 20 kilogram weight load is attached to the block and is passed over a pulley to hang freely on the left side, just like we can see in the diagram here. डायग्राम के अंदर हम देख रहे हैं आराम से कि ये जो 20 किलोग्राम का जो वेट है, तो वो यहाँ पे डाला हुआ है, attached to the block and it passed over a pulley to hang freely on the left side. Okay, तो left side मतलब ये डायरेक्शन में, ये वाला जो वेट है उसकी बात कर रहे हैं वो, ठीक है. Okay, on the right side there is a 2 kilogram weight pan attached to the block and freely. Okay, that means at right side मतलब ये इस तरफ यहाँ पे ये 2 किलोग्राम का पैन लटक रहा है. Okay, so weights of 1 kilogram weight each can be added to the pan. Okay, मतलब इस पैन के अंदर हम एक किलोग्राम का वेट ऐड कर सकते हैं. देखो यहाँ पे मतलब जैसे एक किलोग्राम ऐड कर दिया, फिर से 1 किलोग्राम और एक किलोग्राम, इस तरह से पैन का खुद का वेट तो 2 किलोग्राम है, but we can just add a weight of 1 kilogram each in the pan. Okay, the minimum how many and maximum how many such weights can be added into the pan so that the block doesn't slide along the table. Okay, that means what we want is a minimum how many weights should be added to the pan so that block doesn't slide along the table, and maximum how many weights can be added to the pan so that the block doesn't slide along the table. See here, first of all we'll just consider the equation of motion of this body. ये बॉडी के ऊपर कौन से फोर्सेस काम कर रहे हैं वो एक बार अगर चेक करो ठीक से, तो देखो ठीक से, ये बॉडी जो है तो 35 किलोग्राम उसका वेट है, तो उसके ऊपर कौन से फोर्सेस काम कर रहे हैं. See, first of all we'll just try to find out the minimum weight on the pan. Okay, so minimum weights जो इस पैन के अंदर ऐड किए जाने चाहिए ताकि ये हिले नहीं, स्लाइड ना हो. तो it will be such that in that case, see, one force is acting on this pan in this direction which is due to this 20 kilogram weight here. तो ये 20 किलोग्राम का जो फोर्स है तो वो यहाँ पे ऑलरेडी काम कर रहा है इस तरफ लेफ्ट डायरेक्शन में, उसको हम यहाँ पे ड्रॉ करेंगे by a vector in this way. Okay, so this vector represents a force acting on this body which is fixed only. It is fixed, it's not going to change. How much it is? 20 kilogram weight. Okay, that means it will be, अभी देखो कोई भी 20 किलोग्राम का वेट जब ऐड काम करता है तो उसके ऊपर फोर्स कितना काम करता है, तो we can just say that it will be mg. फोर्स के लिए फॉर्मूला, वेट के लिए फॉर्मूला क्या होता है? mg. तो इसलिए इस पॉइंट पे जो वेट इसका काम करेगा जिसको हम बोल सकते हैं 20 into g. The same force will act at this point here on the body, which will be actually 20 into g, we can say. Okay, 20 into g. Just hold this in the mind. Okay, इसको अच्छी तरह से याद रख लो. 20 into g, where g is going to be 10. Okay. Now, what is the another force acting on the body is the frictional force, which is going to be 10% of the weight of the body. Okay. And now, since we are finding the minimum force here, so the frictional force will be trying to oppose the motion of the body, and hence the frictional force will be acting in the backward direction like this. So this will be the direction of frictional force on the body. Okay, तो ये जो frictional force है तो उसको हम दिखा देंगे यहाँ पे इस डायरेक्शन में, ठीक है, जो कि 10% ऑफ इट्स वेट रहने वाला है. अब देखो वेट कितना है उसका? 35 किलोग्राम मल्टीप्लाई बाय जी विल बी द वेट ऑफ द बॉडी. बट उसका अगर 10% ढूंढ के निकालेंगे तो वो कितना मिलेगा हमको? So that means 10% of, you can just say frictional force. Actually वो हम orally भी कर सकते हैं, लेकिन just write it down. Frictional force acting on the body, it is actually given to be 10% of the weight of the body. Correct है? So that means we have to find out the 10% of the weight of the body. Okay, so 10% का मतलब हो गया 10/100, right? And what is the weight of the body here? It is 35 kilogram. ये तो mass हो गया, but it should be multiplied with gravity g, so as to get the weight. So you can just get the weight of the body to be simply equal to 35 times of g. Okay, that means we can just cancel out this 0 from here, and just we can get this 35 by 10. That means it will be simply 3.5 into g. Okay, 3.5 g. This must be the frictional force, we can say. Okay, frictional force. Okay, so this is the frictional force which is acting in this direction, Fr, we can say, which is going to be 3.5 into. Okay, and here it is the 20 g force, which is applied force acting on the body. Okay, so in this case, what the minimum weight should be put in this pan? If we can call it as a m1, or we can call it as mass m1. Okay, m1 ही बोलेंगे उसको, जो कि मिनिमम मास यहाँ पे डालना है. लेकिन यहाँ पे ऑलरेडी पैन का वेट, पैन का जो मास है वो 2 किलोग्राम है, इसलिए ये टोटल मास यहाँ पे कितना हो जाएगा? सो वी कैन जस्ट से दैट दिस विल बी m1 + 2. ओके, m1 + 2. तो जितने भी यहाँ पे नंबर हम डालेंगे, मास यहाँ पे डालेंगे इस पैन के अंदर, तो वो m1 + 2 करना पड़ेगा हमको, एंड दैट इज टू बी मल्टीप्लाइड विथ g, so that we can just get the weight of that here. तो इसका पूरा वेट निकालने के लिए हमको यहाँ पे m1 + 2 into g करना पड़ेगा, which will be the third force acting on this body, which will be acting in this opposite direction here. तो यहाँ पे एक्ट होने वाला ये थर्ड फोर्स बन जाएगा, जो कि m1 + 2 into g इस तरह से काम करेगा. But now for the equilibrium of this body, okay, ये body equilibrium में रहने के लिए क्या जरूरी है? Sum of all the forces must be actually 0. That means the leftward force, which is going to be this 20g, must be equal to the sum of this m1 + 2 into g plus 3.5 times of g. ये तीनों का हमको equilibrium condition consider करना है. Okay, so you can just have this equilibrium to be simply F must be equal to the Fr plus, इसको हम क्या बोलेंगे? एक्चुअली Fr ये है, रेड कलर से जो एक्सप्रेस किया हुआ है वो Fr है, तो उसको हम ऐसे लिख देंगे m1 + 2 into g, ऐसे डाल देंगे. तो F is going to be 20g, which has to be equal to Fr, which is going to be 3.5g, and here it is m1 + 2 into g kept as it is. Here we can just note that g is present in every term, so we can just get rid of that by dividing by g and get this as 20, which is equal to 3.5 plus m1 + 2 only. So m1 + 2. So if we just add this 3.5 and 2, then we can just get this 20 is equal to 5.5 plus m1. Okay, and then we can just get this m1 by just transferring this 5.5 in that side, so as to get this 20 minus 5.5, which comes out to be 16.5. Okay, no, sorry, 14.5. 14.5. Okay, but since we want to find out the minimum weights that can be put here in the pan, ओके, लेकिन हमारे पास जो है वेट्स जो है वो या तो 1 किलोग्राम का ही है ना, 0.5 का वेट तो हमारे पास है ही नहीं. ओके, we don't have the weight of 0.5 kilogram, we just have the weight of 1 kilogram only. तो इसलिए हम यहाँ पे एक तो 14 किलोग्राम डाल सकते हैं या तो 15 किलोग्राम डाल सकते हैं डायरेक्ट. तो इसलिए यहाँ पे यस, मिनिमम हमको 15 किलोग्राम का वेट डालना ही पड़ेगा, क्योंकि फ्रिक्शनल फोर्स जो है तो वो एक्चुअली 3.5 ग्राम का है, मतलब 3.5 जी के बराबर का है. और if you just calculate the net force acting on the body without calculating the frictional force here, then the net force acting on the body will be 20 g minus 3.5 g, which will actually be 17.5 into g, no, 16.5 into g. This will be the net force. If you just put the value of, okay, and here, okay, g का वैल्यू 9.8 या 10 ऐसा कुछ दिया नहीं है ना यहाँ पे. नहीं, वैसे भी हमको यहाँ पे नहीं लग रहा है वो. So we can just conclude that since 14.5 m1 is the value of m1 here, but since we don't have the mass of 0.5 kilogram, we can just add this 15 kilogram in the pan so that it will be at rest. तो उसके लिए उसको रेस्ट में रखने के लिए हमको 15 किलोग्राम मिनिमम डालना पड़ेगा, और मैक्सिमम कितने डालना पड़ेगा तो वो निकालने के लिए let us consider this same diagram once again. फिर से यही डायग्राम हम ले लेंगे. But in this case, no doubt we have the forces acting on this body. So the first force acting on this body will be actually in this direction, which is due to this 20 kilogram weight load attached to it, which will be actually 20 g, no doubt. तो ये 20 times of g इतना फोर्स उसके ऊपर काम करेगा इस तरफ. चलो ठीक है. अभी दूसरा, इस तरफ हम मैक्सिमम फोर्स यहाँ पे डालने वाले हैं. इस पैन के अंदर मैक्सिमम फोर्स इतना डालने वाले हैं जो कि वो स्लाइड ना करे. तो अगर यहाँ पे हम फोर्स कुछ ऐड करते हैं, जितना भी हम फोर्स ऐड करेंगे यहाँ पे इस डायरेक्शन में, तो वो फोर्स हम यहाँ पे डिराइव कर सकते हैं. एंड वी कैन जस्ट राइट इट एज whatever mass is put in the pan, we'll just add it with this 2 किलोग्राम. ये 2 किलोग्राम के अंदर ही हमको वो मास ऐड करना है. अगर हम समझते हैं कि m2 इतना वेट हम ऐड करते हैं, मास ऐड करते हैं इस पैन के अंदर, तो टोटल मास कितना हो जाएगा पैन के अंदर? m2 plus 2 हो जाएगा. करेक्ट है, m2 plus 2, and this m2 plus 2 must be multiplied with g once again, and that will be actually the force acting in right direction here, which we can call it as m2 plus 2 into g. Okay, this is the force acting on this body in the right direction. Yes, but on the other hand, one more force is acting on this body, which is going to be the frictional force, which will be towards the left this time. Why? Because due to this maximum force applied here, the body will just tend to slide in this opposite direction here. ये बॉडी जो है वो अभी इस केस में इस डायरेक्शन में स्लाइड करने के लिए ट्राई करेगा, जिसको स्लाइड होने से रोकने के लिए यहाँ पे फ्रिक्शनल फोर्स काम करेगा. और फ्रिक्शनल फोर्स कितना दिया हुआ है? The frictional force is already given to be 10% of the weight of the body, and that's why we can just say that this frictional force Fr is going to be 10%, means 1/10 of the weight of the body, which is 35 kilogram. And this 35 kilogram is the weight, but it should be multiplied with g again, so that you can just get it as 3.5 g once again. So this force will actually be 3.5 times of g in this case. And then we can just get that. So maximum force that can be added on this pan so as to balance can be obtained by just equating all these three forces now. In this case, this 20g and this fr has to be added up together, and so as to balance this rightward force here. So we can just get an equation that is 20g plus 3.5g must be actually equal to m2 plus 2 into g. So if we just cancel out g from all these terms by dividing it by g, we can just get this 20 plus 3.5 should be equal to m2 plus 2 simply, which means the 23.5 again. So it is 23.5 minus 2 should be equal to m2 here. That means m2 is going to be obtained as 21.5 here. So 21.5 kilogram. But again, we don't have the mass of 0.5 kilogram here. So we can just put a mass of 21 kilogram only in the pan so that it will just be able to at rest. ये देखो, ये जो फोर्स है 20 ग्राम का 20g इतना जो फोर्स है वो ऑलरेडी एक्ट हो रहा है इस डायरेक्शन में, and in order to balance that force we'll have to put the maximum force here, and that force will be actually 21 kilogram here. So in this way we can just get the answer to be simply 14, minimum 14 and maximum 21. So 15, minimum 15 and maximum 21 kilogram force should be acting on the body. It should be put in the pan so that it will be at rest. It will not slide along the table. अभी इसमें एक बात है कि 14.5 इसको हमने 15 के साथ अप्रोक्सीमेट किया, और जो 21.5 हमको मिला था उसको हमने 21 के साथ अप्रोक्सीमेट किया. इसका जो रीजन है वो तुमको एक्चुअली फ्रिक्शनल फोर्स का नेचर पहचानने के बाद पता चलेगा. एक्चुअली फ्रिक्शनल फोर्स is a self-adjusting force which adjusts its own magnitude and its own direction on its own. ठीक है, तो फ्रिक्शनल फोर्स ऐसा एक फोर्स है जो उसका मैग्नीट्यूड और डायरेक्शन वो खुद ही एडजस्ट करता है. ओके, एक्चुअली यस. सो फ्रिक्शनल फोर्स का जो फ्रिक्शनल फोर्स के ऊपर कुछ और ज्यादा सम सब जब करेंगे तो तुमको ये थोड़ा सा और अच्छी तरह समझ में आएगा कि why we have just taken this 14.5 approximately as 15 kilogram, and in the next slide why we have taken this 21.5 as 21 kilogram only. ठीक है, सो एक फ्रिक्शनल फोर्स का एक प्रॉपर्टी जो है तो वो हम समझेंगे नेक्स्ट लेक्चर में. सो आज का लेक्चर हम यहाँ पे ऐड करते हैं. We have done some numericals in this lecture today, so we'll just do the remaining numericals in the next lecture next time tomorrow. Okay, so thank you all of you.